Go. There we go.
Howdy.
So, I had this one reset earlier, so let me put this back really quick. So that's what we start with. What we did before was change the shape of it necessarily, and this one we want to change the end. So if you look at y equals x squared plus 2, we want to know what happens when we do something down here. So go to your y equals, and let's put in x squared plus 2.
Squared.
And then we want to graph and see what happens. It shouldn't change the width because you didn't change what was in front of x squared. So, what actually happened to it?
It's not 0 anymore.
Right, this is not 0 anymore. This went up to 0, 2. However, this line, one of the mistakes is saying that this is more narrow. This is not more narrow. It moved the whole thing up. If you put those lines back together, this is going to be the same width. Okay, so it didn't change the width because we didn't change what was in front of x squared. We only changed how it went up or down. So on our paper here, what is our new vertex?
0, 2.
0, 2. So on our graph, we want 0, 2. And if you need to, go back and look at your table. Over here. Now what is it at 1?
3.
3. Okay. So here we have 1, 3. What about at 2? 6. Because what we're doing is plugging this in. 2 times 2 is 4, plus 2 is 6. So instead of starting at 0, we're starting at 2. And we want the correct terminology. So we're going to say that this shifts up 2 units. So we had narrower, we had wider, we had opens down. Now we've got that it has a shift, a vertical shift, up 2 units. So if plus 2 went up 2 units, what do you think minus 2 is going to do?
Down.
Shift down.
Okay, so let's go to our graph. Change this to minus. And the whole key is that you can compare anything to your original function or any other function you have. It may not necessarily be y equals x squared. But whatever you start with, make that one the dark one, and then make the other one where you can see what the difference is. So here, what is our vertex?
Negative 2. 0, negative 2.
0, negative 2. And what is it at 1? Negative 1 and 2?
2.
Is it 2? Because 2 squared is 4, minus 2 is 2. So this one is starting down here. And we had a shift down 2 units. And those are the main 2 things that's going to happen. You're going to change the number in front of x squared to make it more wide or more narrow. Or you're going to change the number at the end, which makes it go up and down the y-axis, just like it did for y equals mx plus b. This is your y-intercept, whatever that number is. Okay, let's look at an example of where we would use this in a problem. Flip over to like the 3rd page and look at number 4. This says, which graph represents a function y equals x squared plus c when c is greater than negative 2? Okay, c is our y-intercept. It's at the end. It says greater than negative 2. So look at A. Can that be our choice?
No. Yes.
Is negative 4 greater than 2?
Yes.
Negative 4 is greater than negative 2? No.
No, it's not.
Okay, never mind.
That doesn't work. What about 2? Will that work?
B will.
Yeah, that can work. What about negative 2?
No, it's even.
No, because it's even. If I had an equals to sign under it, that could be true. We don't. So this doesn't work. What about D?
No.
No, because it's negative 3. So this, which the function would actually be x squared plus 2, okay, that satisfies our situation up here. So we have to be careful that whichever one that we're looking for works.